we are ready to implement this timer here. Now, this is the number of seconds left. You have 10 seconds to play this game. And we need the UI to reflect the countdown. So every time we have a countdown, we need the UI to trigger a render. This means that we need to place this logic here on the state of the component to enable React to re-trigger a UI render for every second that ticks. So let's call this new concept seconds left, and let's give it a new state element. So I'll do seconds left, and I'll do set seconds left in here. And this is a use state call. And the initial value of the seconds left is 10 seconds. That can be customizable later on. The seconds left is something that needs to be rendered here instead of the hard-coded 10 that we had in this dev, and test that. Now in JavaScript, when you need to start a timer that ticks every second, you have the option to do a set interval. This set interval function can be a way for us to implement this countdown feature, but we can also implement it by taking advantage of the fact that React will invoke our star match function here every time a state changes, and the state is going to change every 1 second at minimum. Which means we can also use a set timeout call to implement this exact same feature because we know that the star match function is going to be invoked every second. Using set timeout here is a bit more interesting for you to understand the nature of a React component's side effects. So let's implement the countdown feature with a simple set timeout call. But before we do, we need to understand how to implement side effects in React. The only React hook we used so far is the useState hook. React has a few other hooks function, and one of them is useEffect. This, of course, is React.useEffect, but it's available here globally in the playground. This useEffect is exactly what the name suggests. It is a way for you to introduce some side effect for this component. The useEffect takes in a function, and it will run this function every time the owner component renders itself. So if we put a console.log line here, this line really means that the component has done rendering. You'll see this line every time the component is done rendering. So when I click on a number here, the component has to re-render itself because the state has changed. And when it's done rendering again, it will console log this line. And it will continue doing that every time the component renders. Which means we can introduce our own side effect right here inside the useEffect in here. We need to set timeout after exactly 1 second and give this set timeout a function to basically change the seconds left and decrement the current value by 1. So we can use the set seconds left here, and the new seconds left would be the existing seconds left minus 1. Very simple. And guess what? Because useEffect is going to set the state in here, and because that set state is going to cause React to re-render the star match component, the useEffect is going to continue to run, and this will actually make a loop. You can test this right away. The seconds left are going to start ticking immediately, and we don't have any exit condition from this loop, so we need an exit condition. Because right now, it's just going to continue going under 0. So in here, we could introduce an if statement to exit this looping mechanism. And the if statement is basically if the seconds left is still greater than 0. Only in that case, introduce a timer. But once the seconds left are 0, then don't do this timer again. So now the timer should tick all the way to 0, and then it will stop because this condition is going to stop it, and we will not introduce a new timer when the seconds are 0. Cool, but here's the thing. This useEffect is also going to run when the other state changes. So when I click a number to mark it as candidate or used, the useEffect is going to trigger again. Which means if we run this code and start clicking numbers, this timer is going to be created far more often than we need to. And that might introduce bugs if you're not careful, because every click here is triggering a useEffect call, and it's creating its own timer. The good practice here is that whenever you create a side effect, you have to clean that side effect when it's no longer needed. The useEffect hook has a mechanism for us to clean the side effect when it's no longer needed. So let me show you this mechanism. Let me comment out this timer code and we'll get back to it later. The mechanism to clean a side effect is in the returned value of this callback function within the side effect. You can return a function here, and React will invoke this function when it's about to unmount the component, when it's about to re-render the component. So in here, the console log line could be something like, this component is changing. And React is going to invoke this function every time it sees a change in the component and the component needs to re-render, or even when the component needs to be unmounted. So remember, the effect itself run every time the component is done rendering. Done rendering. In here, the component is changing and it's going to re-render. So the component is going to re-render, basically. These are the two mechanisms for introducing a side effect and cleaning up that side effect. So if you render this code in here, you'll see that the component is done rendering. And when you click any number, you'll see how the component is going to re-render, and it rendered, and then it's done rendering. And this happens on each click. So what we need to do for our timer is to basically clean up any timer that we introduce in one render cycle if the component is going to re-render. To clean up a timer, the setTimeout call gives us back a timer ID. So we can capture this timer ID in here. And to clean the timer, to remove a timer, all you need to do is call the clearTimeout call on this timer ID. So in here, in the same if statement, we could return the cleanup effects. The cleanup effect is to basically call the clearTimeout call on the same timer ID. So now, every time the component re-renders itself, we will remove the previous timer and introduce a new timer. And this way, we will be sure that there will be no timer conflicts. You should always get in the habit of cleaning up after your effects. If you introduce an effect, you should always return a function that cleans up after that effect. However, introducing this cleanup function actually introduced another issue with this timer. And you can see that one in action if you click on one of the numbers repeatedly. You'll notice that the timer stops. Basically, you can cheat on this game if you need more time by just repeatedly clicking on a number. This is because the useEffect runs on every state change, and now when it does, it resets the timer that's trying to decrement seconds left using the new cleanup function. So when we click on a number, we're also resetting the timer. Because this is just an enhancement, I'll leave this issue as is in the first version of the game. However, I wrote an article with more details on why this problem is happening and the few ways it can be solved. You can check that one out at this URL. So we have a timer, and that timer is ticking down all the way to 0, and we can play and win the game before the time runs out, but we should also change the status of the game to done when the time runs out, and actually have a different message based on whether the time ran out or the player was able to pick all the 9 numbers before the time runs out. So this game is done condition can change now and account for the time. So we need to do one more condition about when the game is over. Let's actually create a new variable. Call this variable game is lost. So the game is lost when the seconds left are exactly 0. And we should probably change game is done to game is won. If you're able to take all the available numbers down to 0, then you've won the game. But if you run out of time, you lost the game. And the game is done if either of these two variables are true. But here's the thing. Instead of managing 2 states about the game status, how about we come up with a single variable that represents the game status? So let's do game status in here. And we can put the same condition to figure out the game status. If this is true, then the game is won, right? And if this condition is false, then we need to check the other condition. Are we out of time? If we're out of time, then the game is lost. Otherwise, the game is still playing. So maybe we call that status active. So this one game status variable capture these two computations. And it's usually better to have a single variable rather than two variables that are falling in the same scope of computations. Now, if the nested ternary here is bothering you, that is really not the point. You can have two if statements here to replace the nested ternary, or even have a function to compute the game status on every render. But I'm just going to move on. Now that we have game status, we need to determine here whether to show the play again or the stars display. The condition is now, if the game status is not active, you need to show the play again. You show the play again in two cases, when the game is won or lost. Also, let's pass the game status itself to the play again component in order to show a different message if the game is won or lost. So we pass game status as game status in here. And in the play again component, let's introduce a message. So we'll put that in a new dev here, give it a class name of message. And the message here will need to be different if the game is won or lost. So we know that the game status is not active here. So we can just introduce a condition. And the game status is part of the props of this component. So props game status. And we can simply have an inline condition here that says if the game is lost, render the message game over. If the game is won, render a message for the winners. We can also use the exact same condition here to style this message and show it in a different color if the game is won and a different color if the game is lost. And for that, we can use React's style property and in here pass in an object that is based on the same condition. We can, for example, change the color of the message based on the props.gameStatus condition equaling to lost or won. If it's lost, show the message as red. And if the game is won, show the message as green. The act style property is handy to do this inline conditional logic here. That is depending on the component props. And I think we can test. So now if we let the timer runs all the way down to 0, the game should be marked as lost, and the play again should show up with a game over message. But here's the thing. This reset is not working now. Why? Well, because we also need to reset the seconds left to 10. Remember? So when you need to reset the game, you need to reset all the state. And also you need to reset any side effects that you introduce in the game. Now in here, we really stopped the timer, so we don't have any more side effects. But in case you have a side effect, you need to call the cleanup as well when you reset the game. So in the next video, I'm going to show you how to reset the game by unmounting the component rather than by resetting the state. Because when you unmount the component, remember, React will also call all the cleanups that you have. And I think that's a cleaner way to implement the play again button. Before we do that, if you noticed, the timer continued running all the way to 0, even though the game was done. So we should actually stop the timer when the game is won. There's also another bug in this game. When the timer runs out and the game status is lost, the player can still play the game. Let me show you that. So game over, and I can still click those numbers. That does not make sense. There are a few conditions that we need to do, so let's go over them. The first one is right here. We should not introduce a new timer if the game has been won, if the game is done. And the game is done if the available numbers are down to 0. So in here, we should only introduce a new timer if seconds left are greater than 0 and the available numbers are also greater than 0. These two conditions means that we're still playing and we should continue counting down. But if the available numbers are 0, then the timer should stop. The other condition that we need is in the onNumberClick function. If we click a number and the game is actually done, then we should also do nothing. So we could just add another condition here to the same if statement. If the game is not active, right? If game status is not active, or the status of the current number that we're clicking is used, we really should do nothing and not change the state again. So to test that, let the timer runs down all the way to 0 and click again and see if you can click these numbers. You should not be able to click these numbers.